So welcome everyone to another Lead Code tutorial, and the problem we are discussing today is problem number 207, course schedule. Now this problem is another graph problem which has been asked in interviews of many companies. Especially the concept that this problem is based upon is quite common, and you should definitely be handy with this question if you're going to learn that concept. It uses a standard graph algorithm which I'll be discussing in depth. So, without wasting any time, let's move on to the question. And don't forget to leave a like and subscribe to the channel if you like today's explanation, and do share it with your friends. So, first of all, you can pause down the video and read the question statement out for yourself. I'll also be discussing it, so no worries over that. Right. So, I hope that you've read out the question and let's start discussing it. So, what we are given is that we are given a number which is this, and what does this represent? It represents the number of courses, right? Number of courses, which are numbered from 0 to num courses minus 1, right? And then we are given some courses that have prerequisites to them. What does this mean? That for a course A, if B is a prerequisite, then for doing course A you should have already done course B, right? And they will be given as a pair. So a pair will be given like this, suppose 0 comma 1, and to take this course you have to first take this course. That is, for doing course 0 you have to do course 1 before 0, right? So that's what this means, and will be given a vector of vector, will be given a vector of vector, right? This vector is for this pair, and this vector is for vector of these pairs, right? And that's what is given to us in the question, and we have to tell that can we finish all courses. So we have to return a boolean value, right? True if we can finish all courses, and false if we cannot finish all courses, right? So now let's discuss the approach for it. So first of all, the approach that comes to my mind is this. See, let's say for 0, if I have to take 1, I can mark it like this. Let's say for some course number 2, I have to take course 0 and then mark it like this. Let's say for course number 2, I also have to take 1, so I can mark it like this, right? Now here, can I take all of the courses? Let's try and see, right? So for 0, what do I need? I need 1. So first of all, I do the course number 1. For 1, do I need any other course? No, right? So this is done. Now I'll do course number 0. So I've done that, and then finally once I've done 0, I've done 1, I can do course 2, because course 2 required course 0 and course 1, right? So that is done. So that means all the courses I was able to finish, and I have done this, right? Now let's change the scenario a little bit. How? Let's see. Now let's say for 2 you don't need 1, but for 1 you need 2, right? Now let's try and find out, can we do all the courses or not? So let's try for 0. For 0, I must have done course number 1. So let's try. Can I do course number 1? For 1, I must have done course number 2. Now let's check. Can I do course number 2? But for 2, I must have done course number 0. And for 0, I must have done course number 1. But for 1, I must have done course number 2. So you see, what do I find? That this is a cycle. A cycle has been detected, and hence I am unable to do all the courses. So this is the hint, the basic hint for it, right? And this kind of structure, you can see that this is nothing but a graph. Now let's talk about what kind of graph. So here you can see that the arrow is only headed towards one side. So I can say that this is strictly a directed graph. A directed graph, or as some people like to call it, DAG. Right? Now this problem can be broken into 2 parts. I'll just show you what are those 2 parts, right? So first step I always consider that we have to make the graph. We are not given a graph, we have to make the graph. So the first step is, of course, making a graph. Making a graph. And what kind of graph? Directed graph. Right? So this is the first step. And second step, detecting a cycle. Detecting a cycle. So if I find a cycle, I will return false, and if I do not find a cycle, I will return true. Now let's talk about how can we accomplish this, right? So before moving on, I hope that you guys are clear about how to detect a cycle in undirected graph. If not, I'm just going to brief it out a little. So for an undirected graph, if this sort of a graph is given, I just simply have to judge for any node. Let's start DFS from this node, right? I go to this, and from here I can go to 2. I can go here and I can go here, right? So this is a parent node of it, so I won't go back into DFS, I move ahead, right? And now for this node, is I can go only to this node, but is this node a parent of this node? No. That means a cycle is detected. So if I encounter any node which is already visited but is not the parent of the current node, I say that there is a cycle. This is for undirected graph. Undirected one. Right. Why did I go through this? You'll just understand in a minute. Right. Now let's talk about a directed graph. Right. Let's draw a similar sort of graph that I had. Now you can see I have drawn arrows this time. In the previous one, I did not have arrows. Right. Now, does this have a cycle? Let's see. So let's start the DFS call here. Right. From here, I can go either here or either here. So I choose this node. So I've gone to this node. Now from this node, I have only one option, that is to go to this node. From this node, you'll see that this node is not visitable because this is a directed graph, and hence a cycle is not found. Cycle is not found. However, if I would have changed this arrow, now this is a cycle because from this I can go back to this, and it is already visited. But what is the key point here? That simply judging about the parent is not enough, right? Simply judging if I can reach a node which is not its parent is not enough. I have to also check that this current node that I'm visiting should be in the DFS call when I'm visiting it. Right? You understand that this node should have been in the DFS call while I revisit this node. If this node has already exited the DFS call, then it is not a cycle. In that sense, you can see that if I reverse this arrow as well, right? So when I visit this node from this node and here, right? Let me redraw a different graph again, and you will see, right? So when I start the DFS call from this, and I go to this node, right? And when I visit this node here, right, I mark it visited. Alright. But you can see when I go back into the DFS call, this node is not in the DFS call right now. I again mark a DFS call to it. See, this node is already visited. This is not the parent of this node. But you can see this is not a cycle. Right. So that is what I was trying to point out. That simply visiting a node which is not a parent of the current node will not give us a cycle. Right. So how to approach this? Right. So to approach this, what I do, I maintain a stack. Right. So let's take this graph again. So let's number them 1, 2, and 3. So I start with 1, I push it into the stack. Then I visit 2 and I push it into the stack. Now I visit 3 and I push it into the stack. Now you can see from 3 I can go nowhere. So I pop it out. Let's pop it out of the stack. Then in my DFS call, I return back to 2, right? Can I visit any other node from 2? No. So I pop it out. Now I return back to 1. So from 1, can I visit any other node? Yes, I can. I can visit 3. So I pop it into the stack, right? 3 is already visited, though I don't need to push it into the stack. So I'll not keep it in the stack, right? So from 3, I'll say it is already visited, and I come back to 1, and that ends my call. And finally, I pop this element out as well. So this means that there was no cycle. Now let's create a cycle and try judging this, right? Now let's create a cycle here. So this was my original graph, and how to create a cycle in this. I'll just simply shift this arrow, right? Now this is a cycle, you'll see. I'll show you how. So first I start my DFS call from 1. I push it into the stack. From 1 I can visit 2, yes. So I push it into the stack as well. From 2 I can visit 3 and I push it into the stack. Now from 3 I go into 1. Is it present in my stack? Yes, it is present in my stack, and hence this is a cycle. So if I visit a node which is already in the stack and is visited, that means it is a cycle. So both the conditions should have to be true. It has to be visited and has to be in the stack, right? So that is the algorithm for it. Now you'll understand it better when I discuss it. In code I'm going to show you is going to be divided into 2 parts. One part will be actually making this graph, which was the first step when I mentioned it earlier, and the second is going to be cycle detection, right? And you'll see I'll show you the 2 functions separately, right? So without wasting any time, let's move on to the question. Let's move on to the code. So yes, so this code is for part 1, making the graph. All right. So you'll see that I have defined a variable r, which is the number of rows in this. So this vector, why this r is necessary? Because some courses in the original question statement, you will see that there's this word written that some courses have prerequisites. I'll show you here. Some courses, that means not all, right? Only the given courses will have some prerequisites. Some courses can be taken up directly, right? So that is why I've taken this R, that I will only iterate over those courses that need a prerequisite. A course that does not need a prerequisite could obviously be taken at any moment. So that is why I've taken this R. So if R is less than equal to 1, return true. That is, if only one course needs one prerequisite, I can obviously do this. And if no course needs any prerequisite, that is less than 1, right? So if it's less than 1, that means I'll simply return true, that this course is definitely possible. Now I define 3 things. This visited is to keep the mark of visited nodes, keep check of visited nodes, and this in stack is to check the status of the stack. So we were discussing in the DFS calls, right? There was this stack which has 1, 2, 3 at any point. So this vector, this map, you could also take vector of size r, is to keep a check. Why I've taken map here over a vector? That is because I'm not sure what numbers I'm gonna get. Moving on. So this is graph creation. So as mentioned, that the first value given to it is a prerequisite of the second. So if I was given 0, 1, that means I have to do course number 0 before taking up course number 1. So that was given to us in the question. That's what I've done here to make the graph, right? Now what I do, I iterate over this graph, right? For auto I and m, I go to each value in my graph and I check. If it is already visited, then I do nothing. However, if it is not visited, I check that whether this particular node is creating a cycle or not. If it is creating a cycle, then I return false. Else, if I visit all the nodes safely, then I return true. This is cyclic function is something I'll be discussing in a few seconds, so don't worry, but understand this part, that if it has some value a, b, c, if all of these courses can be taken safely without encountering a cycle, that means that I can take all the courses safely and I'll return true. If at any point I hit a cycle, that means I will return false. What does false mean? I cannot complete all courses, not complete courses. All right. So that's what this is. So now let's move on to the is cyclic function, which is the crux of this problem, the most important part. So make sure that you're paying attention for this part. Right. So this is the snapshot of it. Now let's discuss this. So this node is the beginning node, right? Beginning node, that is from where I'm starting. And you'll see here the parameters of the function I'm discussing is that I have sent the visited map, the graph itself, and the in stack. And you can see this is passed by reference. This is also passed by reference. Everything is passed by reference except for the node, right? So this node is where I'm beginning my traversal. So if I'm beginning my traversal from this node, this is this node, right? And subsequently I'll be sending its neighbors as node, right? So this is a standard thing. So first of all, I mark this node as visited, that yes, that I visited, and I push this node into stack. What does this mean? This means pushing into the stack. Pushing into the stack. All right. Now let's check this. So first of all, I check that if my current node is not visited. So if I'm doing like this, so if this node is not visited, okay, sorry. If this node is not visited, only then I will try to find a cycle. Otherwise, if it is visited, so suppose it has come like this and I've already visited this, then I do not need to revisit it through this node, right? That means this node has already been visited in the DFS call for some other node. So I am done with this. So if it is not visited and is cyclic, right? That if this node further in its graph like this contains a cycle, right? This could be like this, right? So if I show you an example, that this and this node, this is not a cycle, but let's say I am here, and what if this has further connections like this, right? So this you can see here is a cycle. So if this node is not visited and it is a part of a cycle itself, or this node is already in the stack, right? That this node is visited and it is already in the stack, which I was discussing earlier, right? That if I'm visiting a particular node and it is in stack, which was for this case, that when I'll be visiting this node in the DFS call of this node will already be in the stack and it will already be visited. So this is a cycle. So this checks for that. If these conditions are true, I return true, that yes, cycle exists, right? Otherwise, at the end of the DFS call of the node, right, after this loop, you'll see my DFS call has been ended. So after the end of DFS call, I pop this node out of the stack, which I was doing. So I pop this node out of the stack and I return false, that is, cycle does not exist, right? So you'll see, and if it returns true, so don't confuse here. If cycle has returned true, it means that cycle exists, and if cycle exists, my answer is false. And if cycle doesn't exist, my answer is true. So don't confuse true and false here. This is for a different condition, right? This is for the question, and this true and false is for the cycle detection. All right. So that's the code. Now let's try and submitting this code, right? So let's try and submit. So you see, this is the same code that I'm submitting. and yes, it passes all the test cases. So that was all about it. I hope that you've understood the entire question. I hope that you've liked the video, and if yes, don't forget to leave a like and definitely subscribe to the channel. I'll be coming out with more videos and more graph algorithms based on maps, hashing, and other interview problems. So see you then, and until then, keep coding, keep learning. Thank you for joining.